Morning. Thank you all so much for being here. This is certainly a crowded and packed room, so appreciate everybody coming out. Hopefully checking in and everything was straightforward. Super excited to welcome everybody here today. We have a ton of exciting announcements. But before we jump right into that, I think in addition to this being our first ever HashiConf on the East Coast, it is in fact the 10th anniversary of HashiConf today as well. Yeah, the first one ever, I think, was about 150 people in Portland, so fair to say it's a little bit bigger today. So with that, I want to dive right in. We have a bunch of great stuff planned for you today. I think one of the interesting things for us as we start talking about 10 years later of HashiConf is we've learned a lot about how organizations do cloud well, right? I think 10 years ago, we were all in sort of the cloud is new, we're figuring it out. What does it look like? How do we think about the tools, the organization, the process? 10 years later, I think it's clear there's some patterns, right? And so one of the things that's really clear to us is there's this notion of the application delivery chain, right? And we almost simplify it down to really thinking about sort of 4 categories, right? One is around application lifecycle management. Think about systems like GitHub, GitLab, et cetera. Then you have infrastructure lifecycle management. So how do we actually build, create, manage the lifecycle of the infrastructure that the applications run on? Then you have security lifecycle. So we think about keys, certificates, API tokens, all sorts of sensitive information that we need to broker access between applications and users and various systems. And lastly, how do we make sure all this stuff is up, running, secure? There's sort of a monitoring lifecycle as well, right? And so for us, what we've noticed is, great, these are the different challenges. As HashiCorp, we really focus on the middle two. And I think for us, we've been increasingly focused on how do we make that simpler for organizations? How do we get more prescriptive? How do we sort of share best practices of here's how we think is the right way to do it? And more than that, how do we start integrating the various workflows when you think about those life cycles around infrastructure and security management, right? So obviously, there's many different products in the HashiCorp portfolio. But ultimately, they're in service of these 2 different challenges. How do you solve the life cycle of building, managing infrastructure? How do you solve the security life cycle? So today, I'm going to focus in on infrastructure. And then tomorrow's keynote will be focused in on security life cycle. So with that, I want to make sure we're all awake. So we're going to start with a pop quiz. What is this a picture of? If you guessed a room of developers that care about patching, you'd be correct. So one of the things we've learned is when you think about that life cycle of infrastructure management, there's different concerns between the different teams, right? You have a set of things that are ultimately developer concerned. They tend to care about their application, the life cycle around that. And then you have things that are operations or platform concerns that care about the infrastructure itself. So you might say day 0, OK, we need to create the actual foundation for the app. This might be the core VPCs, the underlying networks. We're doing direct connect between cloud and our data center, et cetera, et cetera. Tends not to be an app concern, it's an infrastructure concern. That then enables, we get to day 1, now our app teams can actually deploy their applications. That's what they tend to care about. And then you get into the rest of it, which is the care and feeding, right? OK, yes, I still don't just deploy once. I typically have an update life cycle, so you think day 2, day 3, and beyond. But then the underlying application infrastructure, too, you have to patch it, deal with drift management, security incidents, all that kind of fun stuff, all the way until day N when you say, I don't need it anymore. We can decommission everything, right? So when we talk about life cycle, that's really what we're talking about, right? So for us, we look at it and say, OK, how do we simplify that process of building the infrastructure, deploying the applications, and then managing it throughout that entire life? So then, if we talk about patch management, and we start there, there's a number of ways we can do patch management. Sadly, probably more common than we'd want, one answer is not at all, right? I think we've probably all seen this one. The next one, which may be slightly better, is manual. It's the the oh shit moment with log4j. OK, let's go deal with this. All hands on deck. I think the slightly more mature version of it is, OK, we actually have proper configuration management. We're using tools like Chef, Puppet, Ansible, CF Engine, pick your favorite. And we're creating the infrastructure with it, but then doing the ongoing lifecycle patching with it. Ultimately, we think the best case scenario when you get to a level of high maturity is you move to a golden image model, right? You actually pre-bake your images using configuration management tools. And that way, you're baking in all the patches, the software, the agents you need, et cetera. But then we move to a world of discrete versioning, right? I know I'm running version 10 of my image with all of the patches and software that includes. And then when I move to version 11, I can talk about discrete versions. I understand everything about it. So we created HCP Packer and Packer really to solve that challenge, right? I think many of you use Packer to bake golden images, create image factories, and move to that kind of golden image model. I think one of the biggest asks we've seen is help us have more metadata, right? When we're creating these images, great, I know I have this image, but how did I create it? What was the software that went into it? What was the Git SHAs associated with the config management that I had at that moment when I built that image, so that if I have an incident, I know what exactly was a part of that. So one of the first announcements I'm excited about is the introduction of CI/CD pipeline metadata within those golden images with Packer. So now if you're running Packer within your Jenkins pipeline or your GitHub Actions pipeline or pick your favorite, Packer can pick up a whole bunch of that metadata. And then it can annotate that in when it creates the image. So then you can go back and say, great, show me exactly what was the Actions pipeline this ran in. What was the Git SHA it belonged to? What branch did I build against, right? What OS version, Packer version, et cetera. So all that metadata gets captured, and so if you're using HCP Packer, you have sort of a single registry that has all of that information. What that then helps with is as we start thinking about multiple environments and mapping those to different versions, you can leverage environment channels, right? So you don't necessarily want to have one image that you're using in all of your environments. You might have your latest image that you're using in dev, maybe a slightly older one in test, and maybe your hard-end tested image that's running in prod. And so you can use the environment channels to manage those different mappings, manage promotions. If something goes wrong, V12 doesn't work, you can do a rollback. So environment channels adds this powerful ability to leverage golden images in multiple environments. Now, I think this manages the first half of the problem, which is creating the images, but what about the infrastructure itself? I think when we talk about Terraform and multiple environments, I think many of you know the sort of standard best practice here is you end up creating multiple different workspaces based on the same configuration. So you'll have one config, and you'll apply it multiple times into your dev, test, prod environment, right? And this works fine. It just results in somewhat more work in the sense of you have to manage the multiple environments, you have to be aware of multiple workspaces, and then manage that promotion workflow from dev to test to prod on your own. So we started introducing this concept around what we call Terraform stacks. And the idea of a stack is, well, what if Terraform was first-class aware, not just of one config and one environment and one set of state files, but of a richer topology where you might have multiple layers of components. For example, you might have your underlying VPC and then your Kubernetes app that sits on top of that. And you might have multiple environments as well, dev, test, prod. And Terraform could be aware of that entire thing. So this was a concept that we've started introducing on. We've been working on it for a while, really thinking about how do you evolve Terraform to solve that next level of challenge. So I'm super excited today to announce that we're taking Terraform stacks into public beta. I'm personally super, super excited about this one. I think once you play with it, it really does feel like Terraform 2.0 in many ways. It brings an incredible new richness to Terraform's understanding and ability to model complex environments. So I want to make this a little bit more real and go through sort of a real-world example of what this looks like, right? So I want to start with basically what does a configuration look like if I have multiple component layers, right? So here we're going to take a very classic example, which is you might start by saying I want to define the underlying Kubernetes cluster. So here we're going to spin up, let's say, an EKS cluster in Amazon. And then I might have a Kubernetes app that's deployed on top of that cluster. Now, in sort of classic Terraform, you'd almost have to break this into two different sort of configurations because the planning phase of your Kubernetes app would almost always fail when the cluster doesn't exist, right? You'll get a provider error saying it can't talk to the cluster, right? Now you can model these as two different components, and the fact that there's a dependency between them, right? The fact that the second component depends on the Kubernetes cluster created in the first, Terraform automatically figures out, OK, these things implicitly have a dependency. I have to create the first before the second. And we can solve this in a bit of an iterative way. It doesn't dump that burden onto you to split the config and think about it, right? On the second side, we might model now multiple environments. To keep this simple, we just have two environments. We have a development environment, and we have a production environment, right? You could model this in an arbitrarily complex way. You could have dev, test, stage, prod, multiple prods, prod east, west, Europe, et cetera. But we're going to keep it simple for the sake of this example. But now Terraform is aware of the fact that you now have these multiple environments. This becomes a first-class concept that it can orchestrate around. So what does that actually look like? Now we can actually model these things at a higher level, right? Before, if you looked at a Terraform workspace, it didn't really know what environment does that belong to, what components are part of it. Now if we look at the UI, we can get a rich view of, great, I have multiple different environments. I have development and I have production. One of them is fully deployed. The other one hasn't yet been deployed. If I click into one of these, like the development environment, I can see the multiple components, and I can see that multiple planning and execution phases had to take place to get that thing to where it is. So already this allows us to now have a much more first-class modeling of how we think about more complicated application and environments. But more than that, it starts to unlock us doing much more interesting types of orchestration. So the first new capability that Stacks enables is what we call deferred changes. In sort of classic Terraform, again, if I had a Kubernetes app that depended on the cluster and you ran Terraform plan from a blank state, you'd get an error message. It would say, I can't complete the plan because I can't talk to the Kubernetes cluster because it doesn't exist, right? You haven't created it yet. Now with Stacks, it sort of figures out, OK, actually, I won't be able to do this in one plan because you're sort of crossing an impossible planning threshold, right? I have to first create the cluster before I can talk to the cluster. So I'm going to split this into multiple plans. That is what we call a deferred change. It knows I can do a certain amount of work, and then I have to defer the next piece of work until I've made some partial progress. And this allows you to do an incremental plan, apply that gives you high confidence as to knowing exactly what this next step is, rather than when Terraform would either give you an error or would just say, everything is a computed value. I can't tell you what I'm going to do, right? The next thing that we can enable now is what we call orchestration rules. Because we have a first-class concept of environments, and you have a first-class concept of these components, you can now bring various logic in. So this is a very simple orchestration rule that basically says, as long as it's my development environment and it's a non-destructive change, auto-approve, right? I don't want to have to even look at the plan, just run the plan and go directly into apply. It's non-destructive, it's development, I don't care, right? You can imagine bringing much more complex logic in as well, but it's a very simple example. We'll see how this works. So let's jump right into a demo and look at this real-world application. So first we'll go in and we can see this components file looks like HCL. It's exactly what we saw before with these two different layers. And then from there, we would capture our deployments as well. So if we look at the deployment objects, we'll see the same thing. We got the development, we got production, and now we have our orchestration rule that allows us to auto-apply this as well, right? So from there, we can actually go ahead and execute this. So you can trigger it from the command line. From the UI, you get a much richer experience because you can actually see sort of the multiple dimensions going on at once. And we can go in and see, great, within our thing, we now see that this replanning had to take place. There's this deferred change that we talked about. We have to first create the underlying cluster. You can see there's an error message. We can't talk to Kubernetes because it didn't exist yet. So first, we had to create the underlying cluster. The actual execution of creating that was auto-approved. Because of that auto-approval rule, it ran the plan, ran the execute automatically, and now the kube cluster exists. And then from there, we can go and see that there was a subsequent plan that had to take place. First, we created the cluster, then the Kubernetes app itself. And again, because we ran the plan and then the execution could automatically be approved by that rule, we can see that the plan automatically applied, and now we have the Kubernetes application also running, right? So from there, we can step into the production environment. And what you can see here is there isn't a rule to auto-approve. So the plan ran. We can see there's 23 resources that have to be created. But we're going to manually go ahead and approve. Great, you can actually go execute and go create the underlying cluster here. And then this is going to have that same phased execution that we saw. But unlike development, where our rule allowed it to auto-approve, Terraform is now doing this in an incremental way. We approved the underlying cluster. That ran to completion. Then we can see it did another plan to create the Kubernetes app. It's going to ask us to approve that as well. And then when that finishes executing, both the underlying cluster and the application have now been successfully deployed. And you have the entirety of the stack now running, right? So very, very similar in terms of having the plan and execute style. But now you have this sort of higher level abstraction of the stack that allows us to have this richness. And we can see we can do a quick view at a high level if we want. See that we're now fully deployed in both our development and our production environments, right? So this brings a ton of power in addition to what we've had previously. Super excited that this is now available in public beta. We're super excited for you all to play with it, give us feedback, find the sharp edges. There's been a ton of time and attention that's gone into building this. And I think there's a bunch of new capabilities this is going to unlock. So looking forward to hearing from you all in terms of where you want to see Stacks go. So sitting at the very heart of Stacks is this notion of this producer-consumer model. When we talk about those components, generally you're going to have your platform team who's writing those, publishing those, and creating sort of the best practice for the applications, maybe the middleware, your databases, Redis, et cetera, et cetera. And then you're going to have many different stacks, many different workspaces that are consuming those things, right? So you have a small platform team, many hundreds or thousands of consumers in an organization of them. I think the challenge we've often seen with this is then you have this gap between those central teams that are managing those sort of shared platforms, shared infrastructure, and the hundreds or thousands of application teams. And so you end up with sort of this three-legged problem. One is, how do I have visibility into all of this estate, right? Once I have hundreds of different applications, thousands of applications running, it's hard to know, is everything up to date? Is everything running the latest version? But then two, I don't want to go chasing thousands of different development teams. So how can I easily create a change request to say, hey, you're on a deprecated version of the Java module. You need to move to the new version. Or by the way, there's an OpenSSL vulnerability. You need to go patch that, right? Somehow I need to request that these app teams do a thing, right? And then you want to identify and target the right service owners, right? I don't want to have to manually track down who owns what and then go chase them from an email. I want some automated way to notify people, you got to go take some action, right? So super excited that as we've looked at this pattern, we've basically created a set of tools around managing that lifecycle that I'm excited to announce today around what we call module lifecycle management for Terraform. So I think this one's easiest to see if we just jump straight into the demo, and then we can kind of talk about it from there. I think a very common situation is you might write a shared module, and then you have to create a new version of it. Obviously, there's still users on the old version, so we want to deprecate it. So in this case, we're going to take a VPC module, for example. We might select an older version, and we're going to go through and basically mark it as deprecated, right? You can provide a human usable description. It might be security vulnerability. It might be something else. In this case, we're just going to say there's a newer version available. And so this becomes sort of a human-friendly message so people understand, OK, well, why is this thing deprecated? Why do I need to move? Right? So right away, you'll see a banner shows up. Then we can trigger a normal Terraform application that's sort of ingesting then using that module. In this case, we're just going to trigger a normal Terraform run here. And that's going to then trigger it executing here, just like standard. And we'll go see it through the UI. We'll get a better view of it here. And what we'll see is, as now part of that planning and app execution process, what we're going to get back is going to be a message that indicates to the user, hey, you've configured your thing to link to this deprecated module. You're now going to get a warning message, right? So as part of the plan, we're going to tell you, you're using a deprecated module. You probably shouldn't be doing that, right? So this solves the first part of the problem, which is, OK, essentially, we can make that change, and now users who are using it are going to get the message. But what if we actually need them to change? We need you to actually move to the new version. So going back to that visibility problem that we talked about is the introduction of sort of saved views that have been gaining more capability. One is now you can create a filtered view to say, great, I want to filter to deprecated use of modules. So I can zoom in and say, show me my workspaces where I'm using a deprecated particular module. In this case, it's only the one. And now we're going to create a change request to notify exactly those workspaces and exactly those application and service teams and tell them, by the way, you're using this deprecated module. You need to move to the newest version, right? So that's that second part of creating the change request. Could be of security vulnerability, deprecation, new version, architecture change, et cetera. And now from the end user's perspective, they're going to get the notification. And so this could come in a number of different forms. They might get an email message, right, that says, great, you got a thing, you got to go do it. But they'll also get a notification within the UI, within their workspace environment to say, hey, you've got this change request. You're on a deprecated version. Please do an upgrade, right? So this starts to complete that cycle of how do we provide visibility to the platform teams and organizations that are managing a broad infrastructure estate? How do we give you a way to interface with all those different teams as you're managing that life cycle? And then how do the app teams get notified to actually respond and do something, take some action from it? So when we talk about developers having to sort of take action, that leads us maybe into our second pop quiz. Similar room. We're going to take a guess now, what does this room represent? If you guessed developers that love cleaning up after themselves, you got this one right as well. So when we talk about cleaning up after ourselves, I think one of the most common things we see is dev test environments that are left up and running forever and ever, right? Armon needed to spin up his dev test environment. He did something. I went to vacation. I forgot about it. 6 months later, the company's still paying for it. Or I left the company, and the company's still paying for it, right? And so one of the things we introduced was the notion of ephemeral workspace. You could tag a workspace and say, auto-destroy it if nobody touches this thing after some period of time. Now we've introduced that at the project level as well. So now we can create a project. Maybe it's a development project where we have many different workspaces. And we can set up auto-destroy at that level. So now if we go in, we can go and configure that as a general setting that's going to apply to all of the different workspaces. So the goal becoming now, instead of having to tag every workspace individually, I can have a development project or a test project and not have to depend on the discipline of every workspace being created with the right settings. In this case, we're just going to set it to auto TTL after an hour. Right? If you create an environment and don't touch it after an hour, might be a touch aggressive for most use cases, but great for the purpose of a demo. We're going to go ahead and automatically clean it up. So then if we go back, we see that, OK, great, we actually have 2 workspaces already. These things have already been created. There's some resources associated. So if we click in, we can see, yep, there's a bunch of resources there. There's outputs. So some developer maybe spun this up. They have some infrastructure running, part of their development environment, right? And you can see both of them were last changed about an hour ago. So when the next sort of tick over happens now, it's been about an hour, the system goes through and automatically triggers a Terraform destroy operation. It says, hey, you haven't touched this in an hour. You automatically timed out. So now if we click into those environments, we can see, great, the workspace is still there, but we've automatically run Terraform destroy and cleaned everything up, right? So you can see an auto destroy automatically triggered. There's no longer any resources associated. So this starts to let us get to a point where we drive it through sort of a policy rather than depending on the discipline of our developers to say, make sure you clean it up before you go. And the way a lot of people use this feature is basically say, great, every developer environment, 7-day automatic TTL. You can spin it up on Monday. If you're not using it by the next Monday, great, we'll clean up and reap all those resources. No manual action required. So this is really focused then when we talk about those different types of workflows, right? Module lifecycle management, ephemeral workspaces, a lot of these sort of capabilities are focused on that day 2+. How are we dealing with some of this sort of long-term care and feed? A lot of the community users start by just saying, great, I'm going to drop Terraform into Jenkins or GitHub Actions or pick your favorite. And so to unlock some of these things turns into a bit of a migration, right? And I think that's often a challenge because it might break a workflow. You have to talk to all these app teams. There's some challenge to that. So we've looked at it and said, OK, how do we make it easier to unlock these things without having to change your workflow or replace what you're doing? How do we sort of make it a bit more drop-in on that migration? So excited to announce a new capability that we call Terraform Migrate. So to take a quick look at how Terraform Migrate works, it's quite meta. It's using Terraform to do the Terraform migration to Terraform. So we're trying to figure out how to get a 4th level of Terraform in there, but we're not quite there. But effectively, the way the Terraform Migrate tool works is it looks at your existing configuration and state files. You give it an HCL configuration that tells it what your intended target state is. And then it actually generates Terraform code that will do the migration. So it's a custom Terraform Migrate provider that itself then allows Terraform to run the migration as part of a standard plan apply cycle. And then ultimately, it will result in migration of the configuration and state and resources into your target state. So I think this will make more sense when we actually look at it. So let's say we're starting in GitHub. We have a set of existing Terraform configuration. We have a bunch of our configs already out there. We've run these things. Maybe it's part of a GitHub Actions pipeline. So there's state files associated with it and all that kind of good stuff. So if we click into one of these things, we can see it's going to look like classic Terraform. In this case, our backend state is held in an S3 bucket. We might have multiple different workspaces, right? So you can see there's multiple projects, multiple different kind of configs here. And so these are kind of classic, Terraforms you expect. If we look through our cloud, we see we have no projects, we have no workspaces, sort of a blank slate. There's nothing running at the moment, right? So kind of a target, might say, OK, great, how do I bring these things in now? So if we're using the Terraform Migrate command, when we run Terraform Migrate prepare, it'll run sort of an interactive set of questions. It'll ask us, what's your target state that you want to import? What are the set of actual configs based on what we can see that you want us to import? Do you want us to create a pull request to rewrite the Terraform code as needed to make it map into that configuration? And then when it's done, what it's done is actually generate Terraform. So we can actually see it's generated Terraform code, which is now inputs and variables that's going to use that Terraform Migrate provider. Right? So it lets us go and audit it. Much like with Terraform, we want to focus on operator confidence. So then you can actually go in and run Terraform Migrate, the actual execution command. And now it's just running Terraform. It's going to run the init, plan, and execute process of the code that it generated. And what that's going to do is then suck in all those configurations, create the right workspaces, project hierarchies, move the state files over, and then create the appropriate pull requests. So we can see from the UI, now we have multiple projects that are created. Within them, multiple workspaces. And within them, all the resources that belonged to those that had already been created in S3 got pulled over and imported, right? So it makes it super easy to kind of manage a migration in bulk when you have many of these different environments at play, right? You can see all of these things are running. And then from there, You also have to modify the code, right? Because you had it previously pointing to, say, store it at S3, so you don't want subsequent changes to kind of get out of sync. And so you can see that a pull request was created as well, that then it provides the rewrite as well. So it's replacing the S3 block with the appropriate cloud block, pointing to the correct set of projects and workspaces to map that all over. So it makes it super easy, really a focus for us of like, we didn't want to have to change where the configurations are, how it's running, what pipelines it's a part of, but you want to unlock some of those day 2 workflows that we talked about. OK, I promise you, last pop quiz of the day. Back to our famous room. What are we dealing with today? Now we're dealing with developers who've never heard of AI. I know, I can hear the groan. So speaking of AI, obviously very top of mind for people, also very expensive for most people. So one of the things we've been focused on with Nomad 1.9 is really improving what's that experience of managing large-scale GPU environments, making effective use of those resources, and really unlocking the power of the hardware. So if we're talking about some of the super fancy hardware now coming out and available from folks like NVIDIA, these are now very powerful GPUs, right? You're not just talking about single app running at single slot. They now support multiple instances of GPUs. So you can have multiple applications effectively virtualizing access to the same hardware, having multiple slots on it. So with Nomad 1.9, it's now aware of multi-instance GPUs. So it might detect that that GPU actually has 3 slots. Another machine might only have 1 slot, has different hardware associated with it. And so now within your job specification, you can actually ask for the number of slots you want, and Nomad is aware of that. So it's actually doing bin packing of the GPU hardware as well to make sure you're maximizing resource utilization. You don't want a device with 3 slots running an app that's only using 1 slot and leaving the other 2 idle, right? These are, per hour, very expensive pieces of equipment. So how do you maximize your utilization and density on that? You want Nomad to be aware of it and bin packing those resources as effectively as possible, right? But on top of that, these are very expensive resources, so you want to make sure only the right systems are leveraging it. So on top of just being GPU aware and having multiple slot awareness, you also want to have the right GPU quotas. So you might say, great, within my developer sandbox, I'm going to have a relatively low limit of how much GPU you can use, because I'm saving more of it for my inference stack or my training stack or for my data science team. So now you can impose different amounts of quotas to restrict how much of these resources are consumed by different teams and applications, right? So all this stuff makes it easier to manage these large-scale GPU environments, do it in a way that's cost-effective and efficient, right? So when we talk about all these different things, we're talking so far about low-level Nomad job planning, infrastructure lifecycle management, all that kind of stuff. To me, these are really the plumbing of infrastructure, right? It's the nuts and bolts. Yes, it's there. Yes, we have to think about, we have GPUs, how do we efficiently use them? We have lifecycle, how do we manage that stuff? But ultimately, it is plumbing from a developer's perspective. They don't really care, right? When we think about the classic analogy of plumbing and porcelain, what developers want is they want the porcelain, right? They don't want to have to know the details of the stuff, but ultimately, we end up forcing it in many ways. So for us, we spend a lot of time thinking about how do we sort of elevate the abstraction and deliver a different experience to developers. And that's really been our focus with HCP Waypoint. It's really how do we move away from thinking about that plumbing to really thinking about, well, what's the outcome you're trying to do, right? What I want my development team to focus on is say, I'm trying to build a Java app running in AWS. I don't really care, is it running a container, a VM, a serverless function? It's sort of a detail as far as most app teams are concerned, right? So what we want to enable is that the platform teams can write that as Terraform modules, have tight control over exactly how it works and how the architecture fits, but then hide that behind a template and an application abstraction for the developer who doesn't really necessarily care, right? In addition to the patterns, the other half of the equation is the set of golden workflows. I don't just have a one-time deploy of my app. I have to build new versions, deploy it, things go wrong, I roll back, I have to restart, I want to turn maintenance mode on and off. So there's a whole life cycle of activities that a developer does care about, but again, they don't care how it necessarily works. They want the app to restart. They don't necessarily know that on a VM you're going to do it differently than on a Kubernetes cluster. And so how do we as a platform team define those different actions and activities, but then hide it from the developers who just want to push run, right? So this is what we've really been focused on with Waypoints, this notion of enabling golden patterns, enabling golden actions, and providing that higher level abstraction so they focus on that porcelain experience. So super excited to announce that today we're taking HCP Waypoint generally available. So let's jump in and see what that actually looks like in action, right? So we're going to start by going into Waypoint and creating a new application. And right away, the first thing we're going to select from is sort of a high-level catalog. So we're going to say we want a Spring Boot application, and then we're asked for a few variables. We don't really need to know the nitty-gritty. We give it a name, desired instance count. And that's kind of all we needed to know, right? From there, we hit save. We didn't write Terraform. We didn't have to know Terraform. But you can see in the corner, Terraform is indeed running. Underneath the hood, we're executing a set of Terraform modules. We've created a Terraform workspace. There's a plan and apply running. If we have any policies applied, all of that stuff still is there. But from the user's perspective, they hit run. They get an output URL. And great, my Spring Boot app is running. I didn't really have to care how did that plumbing work, right? Now, when we talked about all of that lifecycle management stuff before, creating a blueprint that scaffolds that runs a Terraform thing isn't the hard part. It's the lifecycle management. So now it turns out, oops, this version of the JDK has a vulnerability. We now have to patch 100 Java applications that are all using it. How do we do that in a way that's not a nightmare, right? And so that's where you start to talk about the lifecycle management again. So now let's say we're going to make a simple change. We're going to add, let's say, a CloudWatch dashboard. So we're going to click all the way through to the underlying Terraform module here. And we can see the source is just Terraform. So we might add a new dashboard here, an AWS CloudWatch dashboard. So we're redefining the underlying implementation of that Java application now, right? So this is going to mean that all of those applications that were built on the previous version are now out of date. So great, we might take this template and say, great, we publish a new version of the module. We're going to now configure basically that template and bump the version. So we're going to say, OK, if you're provisioning, we don't want the old version of the module. We want the latest version. That ultimately changed some inputs, because now we're asking you, do you want this CloudWatch dashboard? So you'll see a little error message on that template that now says, hey, the inputs to this thing have changed. Anyone using this, we now need a new input from you. So if we go to our example application, you'll now see there's a warning for the developers. They say, great, there's a new input. Before, you didn't have to tell us, do you want this CloudWatch dashboard, yes or no? Now you do. So when you apply that update, great. We've now taken in the new variable. You can see Terraform is rerunning, and they're basically taking you from the old version of the module to the new version of the module. And now the developer also gets access to that CloudWatch dashboard. So the goal, again, being here, what the app team cared about was their Java app is deployed. They could care less what the underlying Terraform definition was and that you had to change the JDK or add a CloudWatch dashboard. They want to operate their app. But how do we make that easy between the divide between these teams and their concerns? Now, the other piece of this is great. We've deployed the app, but what if we want to put it into maintenance mode, right? Classic kind of a use case. Previously, with Waypoint actions, they didn't support any sort of input, right? You could just run an action, like restart the app, build the latest version. But with something like maintenance mode, you might say, am I turning it on, am I turning it off? When I'm doing a deploy, what version or SHA do I want to deploy? So you need some amount of input. So one of the things we're introducing, and I'm excited to announce, is variable support for actions. So just like we saw variable input for the templates themselves, right, this allows you to bring those variables to the actions. So let's take a look at what that looks like. So in the same Java application that we already have deployed, in our actions, we can see now we have this toggle maintenance mode, for example. And now it actually takes a variable. Do we want to enable or disable maintenance mode? So we're going to give it true, and we're going to hit save. Again, developer doesn't really have to care. How's that running? Is it running a Kubernetes command under the hood? Is it an Ansible script? Is it a Jenkins pipeline we just triggered? Doesn't really matter to them. Might have changed the launch darkly flag. But they can go to their application now and see that, great, in fact, maintenance mode has been turned on, right? So the goal, again, is let the developers focus on what they care about, abstract it from them, and enable the platform team to drive high levels of standardization. So ultimately, that's kind of our goal when we think about infrastructure lifecycle management. How do we think about it through that lens of building the applications in a way, deploying them, and then managing them consistently through that whole lifecycle? So now I'm super excited to welcome a guest speaker. Travis from Duke Energy is going to join us. And we're going to spend a little bit of time talking about their journey on maturing through infrastructure lifecycle. Join me in welcoming Travis. Thank you so much for joining. Awesome. Well, thank you for being here.
Thank you for having me.
Yeah, our pleasure. Well, maybe just kick us off. I mean, I think many people are from the East Coast, so they're probably familiar with Duke Energy, but not everybody. Sure. So maybe start by just sharing a little bit about what is Duke Energy, what is your guys' mission, and then what's your role there?
Yeah, so if you're not familiar with Duke Energy, we're a 120-year-old company. We're in the Fortune 150s, and we're one of America's largest energy providers. We serve electricity and natural gas to states like North Carolina, South Carolina, Florida, Indiana, Ohio, list goes on. Right now, we're in our cloud and net zero journey with an ambition decarbonization goal. My role with the company is as a senior cloud platform engineer. So my team helps our product teams accelerate their journey to the cloud, deploying their applications to production, things like that. My main role on the team is Terraform Enterprise and our Vault's Community Edition instances. They're currently used by over 400 product teams, I think is our latest number. So the products that you just announced with the module lifecycle registry will make this a lot more scalable. So thank you for that.
Our pleasure. Well, we'll jump into that in just a bit. Well, I think it's fair to say the mission of Duke Energy is fairly critical, keeping the lights on for millions of folks.
Yeah.
So maybe take a step backward. Go back a few years, obviously, before you engaged with HashiCorp, early in the journey to cloud. Give maybe the audience a sense of what was the infrastructure estate like? What was the development process like? Kind of what did the estate look like? Go back a little bit.
Sure. So we were very much a waterfall type of company. It took we had a project, take 6 months, and then we release it. When we first got started, we were a very small incubation, almost like a startup type organization within the larger IT of the enterprise. We were kind of tasked with trying out new products, seeing how and what couldn't help us go, to the cloud faster, right? So the one platform team, or platform company, we used was Pivotal Cloud Foundry. And so the way we got started with HashiCorp was actually through Pivotal Cloud Foundry. They suggested the use of Vault as our secret store and our configuration management. So just out of the box, right? It worked with Pivotal Cloud Foundry. They could spin up an app and it can read directly from Vault. So that was very appetizing to us, and that's kind of just history now.
And that started on premise, basically with Pivotal Cloud Foundry, and then you guys started a cloud journey.
Yeah.
And that's then maybe take us through the journey then of bringing Terraform in.
Yeah. So as soon as we started our public cloud journey, this was all on-prem at the time with PCF. We needed a tool that really helped us manage our multiple cloud environments, right? So AWS, GCP, Azure, you name it. We had tools like Ansible and open source tools like that, and we really wanted one language, one kind of tool that could kind of standardize across all clouds. And since we already had a strong relationship with HashiCorp, we took a look into Terraform. And with its strong provider ecosystem, honestly, we just never looked back. It was just a no-brainer for us. It was backed by the strong engineers at HashiCorp. It was open source, so if we needed a new feature, we could even contribute if we needed to. So. Yeah, we were mainly an AWS shop early on, so CloudFormation was obviously on the table. So when we polled our developers, the HCL language was really more appetizing than a bunch of lines of YAML, for example. So
Got it. And then you framed it as the organization was starting from maybe a bit more traditional waterfall, maybe not quite as automated. What was that adoption journey like of trying to bring in sort of an infrastructure as code, moving to more of an automated sort of agile CI/CD type of a mindset? What was that adoption process?
Yeah, so early on it was actually pretty smooth, mainly because we started out as one platform team and then we kind of slowly onboarded product teams over time. So early on it wasn't that challenging. Where we saw most challenges as we started to scale. So when we started hiring more folks to spin up more applications on more product teams, they may or may not have had a DevOps background. They may not know what infrastructure as code is. So those teams, right, that's where we started seeing a lot more challenges as using Terraform, right? They're like, I'm a Python dev. I don't have to care about the plumbing like you mentioned, right? So, yep.
Got it. Okay. And then, so you started there, started scaling it up, and I think ultimately, where you started was Community Edition, but today are commercial customers. Walk us through maybe what was that transition? What was the trigger? What kind of took you guys from one to the other?
Yeah, so it all goes back to scale. So early on, we managed pipelines. We used an open source tool called Concourse at the time. Basically ran a Terraform plan in one job, reviewed the plan data, then ran an apply job. But as we grew and we scaled, maintaining those templates and helping the teams learn Concourse, Terraform, AWS, the list goes on, just became completely unmanageable. So we needed a tool, we needed a platform that again shifted left, shortened that runway for us and the teams. So that's where TFE came on. The main things we liked about Terraform Enterprise was really, Sentinel. So back when we were on Concourse, we had a tool called Kix. So what we had to do is we automated security scanning into the PR process. So instead of Sentinel where it sits right after the plan, Kix would when you open a pull request, there's a pipeline that goes and scans your code, runs it against the OPA policies, and then comments and either approves or disapproves or unapproves the PR. So the Sentinel was a huge driver for us. What we're really driving for now is the use of the PMR, the private module registry. to help us consolidate our modules. So right now we have them spread out across different projects and different repos. And so when teams come on, they're like, well, I'm just going to reinvent the wheel.
Yeah.
So yeah.
Got it. Makes a ton of sense. And then I know you mentioned at the very start, starting to think about kind of that module lifecycle management piece. Maybe walk us through as you think about kind of day 0, day 1, day 2. Where do the different kind of products fit, and how are you starting to think about that lifecycle?
Yeah, so right now we have a kind of a pre-seeded Terraform template that all product teams start with. There's nothing in there other than the authentication, the backend, things like that, common variables to authenticate to AWS and Vault. But with the module lifecycle, I think that'll really open a lot of doors for us, right? So we're a very small platform team, and maintaining 10, dozens, hundreds of modules is not going to be maintainable for us. We're going to be having to chase down product teams to notify, hey, there's a new version. So I think that'll really open a lot of doors and really help us drive more adoption of modules, and then again, shift that runway and shrink it a little bit more.
And so as you're thinking about those next steps in terms of sort of scaling up, what are you expecting in terms of sort of team growth? Obviously you mentioned like 400 application teams, and how do you think about what set of capabilities are going to help make that manageable? Yeah,
so the biggest thing is probably Terraform stacks. When you announced that last year, I immediately got excited about it, right? So we have small architectures, we have large architectures, and I think Terraform stacks can help us scale and accelerate from any size. So just for starters, right, like a small development team, you only have one workspace, right? How can we use stacks? So right now we use multiple workspaces for different environments, but the built-in environmental features of stacks is like you only have to worry about your one stack, and you just can deploy to all the regions, other environments. It's going to be great.
Well, I was going to ask you about your view on stacks, but it sounds like you kind of beat me to it. So
a little excited, yeah.
No, that's great. So maybe just share a little bit, sort of what's next on the journey. I think you guys obviously started with early, moving to cloud, now getting mature, thinking about sort of that day 2 lifecycle management, leveraging some of those sort of more day 2 automation workflows. As you think about kind of what's next for Duke Energy and sort of next in terms of your usage, what comes to mind?
The first thing that comes to mind is honestly Terraform stacks. Like just being able to use that to simplify like Kubernetes deployments and all of these workspaces or multi-deployments where we have some really sketchy automation that kind of ties them together. Like I need this deployed first, I write a secret to Vault to then use it in another deployment. It's very sketchy. I think that'll be really, really great for opening a lot of doors there. The other thing is really all these module lifecycles. Because right now our biggest issue to scale is the developers don't have time, or they don't want to learn Terraform, they don't care, they just want to make the application, right? So how do we shorten that runway from Fast and Furious to an aircraft carrier? Right. And so all of these enhancements coming to the module, like Lifecycle, being able to like, deprecate them, and the automated generated test that's already out in beta, things like that will really help open a lot of doors to adopting modules, because I think that's the next step for us to be able to continue to scale and continue to flourish with Terraform.
Solving some of those day 2 challenges rather than just getting them on for the day 1, basically.
That's right, yep.
Makes a ton of sense. Well, thank you, Travis, so much for joining and sharing your story. A round of applause for Travis. Thank you so much.
Thank you.
Always great to hear, and thank you, Travis, so much for joining us. Trust me, it takes some nerves, so appreciate another little round of applause for Travis. Thank you. So we've talked about a ton of different things today. I want to just highlight a handful of the announcements. Again, Stacks, super exciting, in public beta. Please go use it today and start giving us feedback. Module lifecycle management and Migrate, hopefully making it easier to move on and leverage some of these day 2 capabilities. Nomad, super excited about, as always, enabling sort of that GPU usage, and then the GA of Waypoint, making a lot of this stuff more accessible to developers. So lots of great stuff, all announced and available today. Please go give it a shot. So as I mentioned, today was really going to be focused in on the infrastructure lifecycle management part of the portfolio. Join us tomorrow for security lifecycle management. But in the meantime, we have a lot of great talks, a lot of great content for the rest of today. There'll be a bunch of deep dives scheduled to go into some of the announcements that we talked about this morning. So with that, I want to hand it back to our wonderful MCs and hope you all enjoyed day 1 of HashiConf. Thank you so much.